Hello everyone, welcome to my channel. Today I am going to talk about reverse engineering POS malware. Now before that, let's talk a bit about how the POS systems work and how does the credit card or debit card look like. So here is a sample of a credit card or debit card. If you see the back side of a card, you are going to see the magnetic strip. This black color is the magnetic strip. So basically this magnetic strip contains a lot of information. The information includes your credit card number, your name, and your expiry date and other information. So this black strip, it has three tracks. So logically, it is divided into three tracks: track one, track two, track three. And track one holds the card number, the owner's name, and the expiration date. Track 2 has the card number and the expiration date. Track 3 is occasionally used for some other purposes like some benefits or something. Now, let us see how track 1 looks like. So track 1 technically looks like this. It starts with B or some other digit. This is followed by a card number. This is followed by a separator that is like a XOR symbol. And second, a name of the owner, and third is the again a separator. This is followed by the expiry date. This is followed by the service code, and then again 4 zeros are there. This is followed by the CVV, and 3 zeros are there. So these track numbers you can find from the internet. I found this from the internet. Here is one of the websites from which I have found the track number. This is one of the websites. Let me just nearpay.com. I went to the website and you can see here there is an option to generate track 1 and track 2, and it is going to generate the tracks for different kind of credit cards. This one is for Visa, this number, and this one is for this is track 1 for Visa. This is track 2 for Visa. Similarly, this is track 1 for MasterCard, and this is track 2 for MasterCard. So let us see how we use it. So let us see how POS machine works. Basically, your POS device, it is connected to one CPU, you can say. So this is the credit card, and what happens when you swipe the card? So when you swipe the card, basically the track 1 and track 2, this information is going to the virtual memory of the POS software. So this computer has one POS software, and the software has a virtual memory like all other software when it is executed. So when you swipe your card, this information, the track related information, the tracks are copied to the virtual memory of the POS software. So there are different vendors. There are different software vendors who provide the POS softwares. So there will be different process names related to this POS softwares. I'm not going to get into details in this video. Now what happens? Now all your track information, which has your card number, your name, expiry date, everything is there in the memory of the POS software. Now, when a malware comes in, a POS malware comes in, what it needs to do is simply scan these tracks, and it will get all the information out of it. And from there, it is going to steal the information. Yeah, so this is basically how the POS malware works. Basically, it scans the tracks, and as I mentioned, there was a certain pattern of the tracks. It is going to find that pattern in memory and then steal those credit card information from the memory. Now, let us look into one of the malwares, that is Neutrino POS. Let us look into that malware at code level. So basically, let me open Kitra. So this is Gitra, and it has the Neutrino POS in it. So I have already analyzed this sample and identified there is a function in this uh, malware which is responsible for doing this was scanning the memory. So basically this the scanning of memory is called the RAM scraping. It is based on the concept called memory scanning. So let us talk a bit about what is memory scanning. So what I have done is I have created a fake POS application. So this is the source code. Basically, what I've done is whatever the track information I've got, I have put that into a variable. So this is one of the track information. This might not be so accurate. This is what I got from the internet, and this is the track 2 information. So basically, I created a program that has this track 1 and track 2 as variables. And when I execute this program is always going to run and it is not going to exit because there is a infinite while loop here, a while loop. Okay, so let us see how it looks in memory. So I already run the program. So this is my program running, and let me open Process Hacker and see how it looks like. This is my fake POS. Let me open it, and you can go to the memory tab here. Uh, yeah, so this is the memory tab here. Uh, and you are going to see like this. So basically, if you see, this is the memory, and the memory is divided into number of small units. I generally call it as pages. Sometimes it is called memory blocks. So here are different memory ranges, 0 to this is 1000, and the size of that the one starting with 1000 is 64 KB. The protection is read write, and mapped commit is the state. Commit is the state of that memory, and mapped is the type. So there are three types of memory: map, private, and image. So I'm not going to get into details further as it is covered in my earlier videos. And this is commit. This is basically state. So there would be the memory page. Generally, it is in commit state, reserved page, reserved, and free state. And free states are hidden because this is here in Process Hacker. It is checked hide free regions. Now let us find out where the credit card lies in memory. The track one lies in memory. So just let me search this memory. So let me go here, and what I do is I go to the strings tab in Process Hacker. Let me reduce this to 5, doesn't matter anyway, and put it to image as well. And after that, what I do, I get the results. Remember to check this. Sorry. Remember to check this image icon here, and let me search it here. And I search my pattern here. So you can see here, it lies in a particular memory region, address 402000. So you can see here, here lies my credit card pattern that is in 40200. This is the starting of this page. So let me get to this page. So this is the page 402000. Okay, so basically for this software, it is going to be constant because I created it, and it is this memory location for this particular pattern would be constant. So let me manually go here, and I can find it same. You see here, this is the pattern. This is a pattern, and I can see it here. Okay, now let us get back. So how will the malware, how is the malware going to find this pattern in the entire system? So first of all, it is going to iterate through the entire processor list of processes. It uses the API process 32 first, process 32 next to do so. And after that, uh, it it is going after that it is going to open some of the processes, not all the processes because it's going to be heavy for it. uh, so it is going to open some of the processes and then uh, extract pages out of it. These are the pages. It will extract all the pages one by one, and then in this pages it is going to find the pattern of the credit card. So if you observe, the credit card has particular pattern, like this one starts with a percentage, that is followed by p, and after b, this is the credit card information. This is the credit card number. This is followed by the name, and this is followed by your expiry date, and this is the CVV. Okay, so this pattern can be found in the memory of the POS software using some regular expressions. So the malware is going to do so. It might search for regular expression, or it might try to find out for this delimiters. So these are the delimiters it is going to find and try to extract the credit card information, the track information. So basically, let me tell it again. So it is going to iterate through each of the process, and for some of the process which it thinks that it could be a POS process, it is going to iterate through all the pages in that process one by one, and then find out the credit card pattern. Okay, so let us look at this theory in as a program. Let me show it as a pseudocode. Uh, So this is the pseudocode which I've created, and this is derived from the decompiled code of Neutrino POS. So if you see here, I'm not going to read the entire code, but basically I'll show you the APIs, how they look like. So if you see here, this create tool 32 snapshot, it is uh, going to get you the list of all the processes in the system. And after that, using process 32 next, it is going to iterate through all the processes. And after that, it finds the process of its interest. It is going to open the process. And after that, it is going to get property of the pages, the first page using virtual query. Then it is going to iterate one by one. So virtual query is going to get the page property. Basically, it will get the page permissions plus the page state plus the page size. So the page size is important here because it has to iterate through all the pages. So basically, if it adds up the page size, if it, if uh, if in the program you add up the page size to the address of the page, you are going to get to the next page. So that's how it works. And after virtual query, it is going to go to the read process memory. So each page which it gets, so it checks for further properties of the pages as well to find something interesting, the pages of its concern. And after it gets to a particular page, it is going to read that page into one buffer. So it is going to read one page from the buffer of the POS software into its own memory. So this is the address of the POS software, and this is the memory. This is the local buffer of the malware. So here it is going to read, and after that, what it is going to do, now it has got the contents of the particular page in its own buffer. Now using this function memory buffer parse, it is going to find out the credit card pattern in the particular buffer. So basically, this piece of code, it is going to iterate through all the pages, and after that extract some of the pages, and then um, scan that page for the credit card patterns. Uh, so after it finds the credit card patterns, it is going to get it to the attacker. So let me show this pseudocode. So basically, this process for this process 30 create tool 32 snapshot, it is going to get the list of processes, and then process 32 first, it checks the first process if it is blank or something. Then it process 32 next is going to iterate through all the list of processes that is retrieved from create tool 32 snapshot, and for each of the for the processes of its concern, it is going to open those processes, uh, and after that it is uh, going to get the pages one by one. So for each pages, it is going to run the virtual query where it is going to retrieve the size, and this size would be added to the address of the current page to get the address of the next page, and it goes on, and this again it is going to um, uh, uh, read the page into its local buffer, and then after that it will search for credit card pattern. So this line is uh, going to get it to the next page. So let me just show it how it is going to work if you cannot understand through the program. So let us visualize this. So left side is the malware process, and there is the malicious buffer here where it is going to copy the pages, and the POS page. So the right side is the POS virtual memory, and the right side is the POS virtual memory, and right now uh, it is pointing to the POS page address, which is the page one, and this page has property address. It is lies in page one, and its size underscore what is the size of the page. So let us see how it works. So when the read process memory is called, so page one is going to be loaded in the mal buffer, and after that the malware is going to scan that particular buffer to find out if there is a credit card pattern or not. If it has not found the pattern, what it is going to do is it is it will go to virtual query in the it will go to the next iteration. It will do a virtual query. From virtual query, it is going to get the page size, and from the page size, it is going to get the address of the next page. That is by adding the address one to the size of the page, it will get address two, and now it has moved to address two. And here if you see it is now pointing to page 2, and now again there is a read process memory, and page 2 is copied to the buffer malware buffer, and again it is scanned for the credit card information. So next is goes to page 3, and again the scanning happens. The same thing is going to happen till it finds the credit card patterns of the tracks. So let us look into the lab. So let us debug the POS malware. Let me switch to my VM. So let me get to my VM now. So this is my this is the malware loaded in the x64 debugger, and I've already manipulated the malware in such a way that it points directly to the RAM scrapping code or the memory scanning code. So let us look into it. So before that, let me show you. So in my VM, I'm running this fake POS application, and the PID of the fake application is 6264 in decimal, which is equivalent to 1878 in hexadecimal. So this is my fake POS. It's 6264 in a decimal, and in hex it is 1878. Okay. So basically, if I'm going to iterate through all the process while debugging, if I'm going to iterate through all the processes and then iterate through all the pages, it is going to take a whole hell lot of time. So I'll use a shortcut here. So let me show you what I'm going to do. So basically what I'm doing is, let me break point on the open process. So I have already done it. So this is my open process, and I've already set a breakpoint in it. So I break in open process, and basically, if I see the parameters of open process, uh, this one is the first parameter, inherit access, and second is the inherit handle, and third is the process PID. So third one is the PID of the process. So basically, if I change this to my fake POS PID, it's going to save a lot of time for me. So my fake PID process in hexadecimal is 1878. So let me do one thing. Let me double click here, and I get a prompt here where I can enter 1878. Okay. So when I do it, I can see here 1878 I've already changed, and this is the fake POS PID. Okay. So now let me step over this API and see what happens. So I'm going to get a handle to the open process that is 29C, which is in EX. So let me confirm it. So how can I confirm? So I usually check this view handles, but sometimes I don't see it. Maybe mostly in case of processes. View view handles. Okay, so basically somehow I don't see it here. So I can check the same in Process Hacker. So in Process Hacker, what I do is I'm debugging the malware neutrino POS. So let me just open it and uh, go to the handles. Uh, Go to the handles here, and if you see here, you are going to see here it's very small. So here it is 29C. It is the handle of fake POS process, which is 264. Okay, the PID is 264. So basically, the process has been opened now. So it seems to work right now. The next, let us see, next after this, the malware is going to call the virtual query, and this is followed by the read process memory. So instead of going breaking point on virtual query, let me directly break point on read process memory. Yeah, so this is the read process memory. So now I already know that the malware pattern is in the credit card pattern is in memory address. Let me check out the memory address 402000. I'm already aware of that because this is the program which I created. 402000. Sorry, wrong location. Oh, oh, sorry. I'm looking at the wrong process basically. Let me look into the fake POS application. So this is my fake POS application. Now in this fake POS application, my credit card pattern or the track one pattern is 402000. So this is my credit card pattern, my track one pattern, which I already put it. in my code, right? Leave this one. Yeah. So basically what I can do is, let me get to the API of read process memory. So if you see read process memory, um, the first one is the process handle, uh, which is 29C, and the second one is the base address. Okay, so base address is the basically the address of the POS, address of the page of in the POS memory. So by default it is pointing to 30,000. Now if I go iterate through all the pages, it is going to take a long time. So let me just change this page address here as well. So basically this is my address, and this is my local buffer, or the mal buffer. So let me change this one, the page address. So let me change it to 400, 402,000. Okay. Uh, this is the address in the remote process, that is in the POS, fake POS application. And this one should be pointing to the local buffer. So let me right click here and see it in dump. Follow D word in dump one. So this is the malmem buffer. So let me see what happens when I step over read process memory. Yeah, so you can see here the track one is copied to this location, right? You can see further all the variables, some of the variables which are pointing to this address, they're filled up. They're already filled up with the track information of the credit card. Okay. Now, if I go further down, here is the point where it is going to take the buffer, which has the track one information, and inside this buffer, it is going to verify if the track one is similar to the track one matches the credit card patterns. The information has a credit card pattern. So basically, this one, I'm not going deeper into it. There is a lot of parsing here. And finally, out of this, if it gets a proper uh, match of the credit card patterns, it is going to send the credit card information to the attacker. So basically, this is verified by an algorithm. The credit card pattern can be verified by an algorithm known as the Loon's algorithm. Let me spell it. Uh, okay. So I don't say that this is the final Loon's algorithm, but there is a possibility. I'm not going deeper into it. So this is how you can debug a POS application. And yeah. So join my training and uh, learn reversing a lot of advanced malware. You can learn about info stealers, ransomware, POS malware, ATM malware, rat trojan, banking trojan. Join my training, malware reverse engineering made easy. Goodbye.